In this video, I'm going to show you how to use your TI-84 calculators in order to calculate binomial probabilities. Now, at the surface level, it's very easy. There's two functions that you need to know how to use, and I'll show you very quickly how to use those in case that's all you really need to know. But if you need a little bit more in-depth explanation as to exactly how those functions work and how to solve problems, I'm also going to give a little bit more detail following. So, at the surface level, we have two functions in the calculator. If you go under the press second and vars, which is the distribution menu, and then scroll down a bit until you see binom PDF and binom CDF. These two functions are the functions that the calculator uses for binomial probabilities. Now, they are slightly different from one another, but not much, and I'll explain the difference in just a moment. But both of them require some inputs. The nice thing about the TI-84 Plus is if you have your stat wizards turned on, when you press enter for binom PDF, it will ask you what values are necessary in order to make your calculations. So for instance, in a binomial distribution, you should know that the two most important inputs are the number of trials in an experiment, and that's generally indicated with a lowercase letter n, and p, which is a probability of success. So those two values are input first here. And then x, that is an optional argument, and it's if you want to come up with a single probability, you would place something there, or if you want to come up with an entire distribution, you can leave it blank. So, for instance, I have a problem over here which says that a certain type of cellular phone has multiple color options, but 38% of consumers purchase the silver model. If a random sample of 8 owners of this kind of phone is randomly selected, find the probability that exactly 2 own silver phones, find the probability that at most 5 own silver phones, find the probability that more than 5 own silver phones, and finally find the probability that at least 3 own silver phones. Okay, let's start with part A here. So find the probability that exactly 2 own silver phones. Now, to give you an idea of how binom PDF and binom CDF work, what I want you to visualize is the entire probability distribution. So this is a binomial distribution. It does have 8 trials, but the probability of success is 0.65, so let me change that to 0.38. Okay, so what we're looking at is a histogram, and the bars of the histogram are labeled from 0 to 8. So we have 0 people in our sample could have the silver model, all the way up to all 8 people. And the height of each bar is the probability that that's the number of people with the silver model out of the group. So for instance, this bar right here represents the probability that 3 people out of the 8 would own the silver model. Now, where do these heights come from? Well, they come from the function binom PDF. And this is exactly the function that's in your calculator. And if you use it in this way, it will come up with these particular values. So for instance, if I set in the calculator the number of trials to be 8, the probability of success to be 0.38, and let's say x to be 3, I should get 0.2815. So let's take a look. So I'll set the number of trials to 8, probability of success to 0.38, and the number of, or x value here, which is the number of successes we wish to observe, to 3. Then when I hit paste, it will just take that function and paste it to the home screen along with the inputs that you have indicated. So you just have to press enter one more time and it will calculate that probability. So the formula it's using is the formula that you were probably told in class, and it's just plugging these numbers into that formula to come up with these probabilities. So that's what's happening here. It's just that I have the problem set up to where or I have this program set up to where I get the value for binomial PDF for every single possible value of x. That creates the binomial distribution, which allows me then to create this histogram. Now, binomial CDF, how does that differ? Well, the way that binomial CDF differs is that it's a cumulative distribution function. That's what CDF stands for. PDF stands for probability distribution function. So the cumulative distribution function tells you that things are being added starting from the lowest value and increasing. So for instance, the cumulative probability for the first output here is just 0.0218. But if we add to that the next probability, so I'll grab my calculator here and tell you what, let me make that smaller so I can see it. All right, so 0.0218 plus 0.1071 gives me the next cumulative probability, so 0.1289. If I add to that the next probability, 0.2297, so take the total so far and add 0.2297, it gives me the next cumulative probability. And it does this throughout the table until we get to the end. So that's the difference between a cumulative distribution value and a probability distribution value. Now, when we are answering questions, we need to know which one to use. So the way that we know which one to use is through the context of the problem. So for instance, part A says find the probability that exactly 2 own silver phones. So what I want is only 2 people out of the 8 to own silver phones. I want that probability. So I pretty much just want to know the height of this one bar. If I just want to know the height of one bar, I'm not adding any bars together. I would just use binomial PDF to do that. So for instance, let me just highlight that bar. All right, so I just want the height of this one bar, and I can see it right here is 0.2297, or using the calculator, if I'm answering any question where I have the wording of exactly some number of successes out of my group, then I know to use binomial PDF. So here, let me just clear this off, and I'll go into binomial PDF, the number of trials is 8 still, P is still 0.38, but this time X is 2. So I'll paste that to the home screen, press enter, and I would get that probability value directly, so 0.2297. So the important thing to remember is that the exactly 2, or the wording of exactly some number of successes out of a group, that's when you use binomial PDF. Now, what happens if we have wording like this, where we want possibly at most 5 people out of the 8 to own silver phones? Well, if we want it to be at most 5, then what happens is we now have a group of items of these probabilities that we want to add together. And what you need to ask yourself is this group of items less than 5, greater than 5, and also, does it include 5? All right, so if we're saying at most 5 own silver phones, then if it's at most 5, it wouldn't be any larger than 5, so that's going to be less than 5. So it's going to be starting at 0, and then the question is, do I stop at 4 or 5? Well, if it's at most 5, that could include, so let's shade that part of the table. Now when I shade that part of the distribution, these are the probabilities that I want to add together. Now, I could absolutely come over here and take all these binomial PDF probabilities and add them together. But binomial CDF has already done that for me. So if you'll notice, this is the sum of the shaded region here. And binomial CDF says when x is equal to 5, the total of all the probabilities from binomial PDF from x equals 0 up to and including x equals 5 is 0.9615. So that's how I would answer this particular question. I would use this time binomial CDF, and the inputs to binomial CDF are the same, so the number of trials in this case is still 8, probability of success is still 0.38, and the value in question is 5, so it's going to add all the binomial PDF values from 0 up to 5 and give me that answer directly. So you do kind of need to know what's happening visually so that you get an idea of how to use binomial PDF and binomial CDF correctly to get your answer. Let's look at the next one. Find the probability that more than 5 own silver phones. All right, so more than 5. So when I think about what that's going to represent, then I need to think first, is this going to be values that are to the left of 5 or to the right of 5? So less than or greater than 5. Well, if it's more than 5, it's going to be to the right of 5. Now, then the question is, so 5 would be my lower bound, possibly. I haven't answered everything. But my upper bound would definitely be the maximum that it could possibly be, which is 8. The last thing I need to ask is, do I include this endpoint? So is 5 included? So if it's more than 5, I'm not including that endpoint. So here's what I need to do. I need to only include 6, 7, and 8. So these probabilities together here, I need to find the sum of. And again, I could take binomial PDF for 6, for 7, and 8 and add those together. But binomial CDF can still work. The only problem with binomial CDF is that it only counts starting with x equals 0 up to a given input. So I can't just do binomial CDF with x equals 5 and get the right answer. But that would give me the sum of all these white bars. And the total of all the bars together is going to be 1. So if I know the area of all these white bars, if I know the sum of all those numbers, I could take those from 1 and then get the sum of these bars over here. And that's exactly what I need to do in order to get that answer correct. So I would take 1 minus, you can just go ahead and put that on the home screen, then do second distribution, come down here to binomial CDF, number of trials, probability of success, they're still the same, and then my x value is still the same here with 5, and I'm going to paste that to the home screen. So now I'm doing 1 minus the previous probability, which is 0.0385. And if you'll notice, this sum of the shaded bars, and this program is set up to only add up the shaded bars, is 0.0385. So we have the correct answer. Okay, now the last one, which is probably the trickiest of all. Find the probability that at least 3 own silver phones. So at least 3. Well, for at least 3, again, ask yourself, is this more than 3 or less than 3? And if it's at least, it's going to be more than 3. So we would start with 3 and go up to the maximum. But then you have to ask, is it including the max? Is it including the 3? So if it's at least 3, that is including. So we would start with 3 this time. All right, so here's my answer, 0.6415. But how do we get that on the calculator? So here's the way that I generally do this. And I don't expect students to actually have the entire distribution to look at. But what you can do is this. You can just kind of think in your head, or you can just sketch out the values that x can take on. Okay? Now, if I use binomial CDF with 3 as my input, well, I tell you what, let me do it this way. So I know what I would like to come up with for at least 3 would be 3 or more. So I want the sum of these probabilities from Binomial PDF. But Binomial CDF could only do, for instance, the sum of these for me. So what I could do is get Binomial CDF 8.38 and 2 to get this total right here, knowing that I could use the complement to that. So the green region and the blue region are complementary, so 1 minus that would give me the blue. Whoops. Now, putting that into the calculator should give me the correct answer. So let's take a look here. So 1 minus 0.3, or sorry, 1 minus, going to distributions and then down to Binomial CDF this time. 8 and 0.38 are still correct. The x value should be 2. So then we paste that to the home screen. Oh, and I've got that 0.3 there that I don't need. I'll take that away. All right, so 0.6415. And if we look at this sum right here, that agrees. So we did get the correct answer. But the reason that this is one of the trickiest cases is because not only do we need to use a complement on the outside of Binomial. Oh, and I'm so sorry I wrote PDF. I wasn't concentrating enough there. Let me fix that. Binomial CDF. So not only do we use a complement on the outside of Binomial CDF, we also don't use this value here directly. We use 1 less than that. So it's a good idea to kind of sketch out, at least in your head, what these would look like so that you make sure you get the right values to input into the functions in the calculator. And that's it.